Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I'm your instructor, Jim Herbie. In this episode, we're going to continue in Module 2 of the exam objectives by discussing Section 2.5, Input-Output Interfaces. Let's begin.
RJ45 connector, registered jack 45. This is the standard connector we use in our wired Ethernet cabling. RJ45 is an 8P8C connector. That means we have 8 positions as well as 8 conducting wires. Within an Ethernet cable, you will have 4 individual colored pair of wires: brown, green, blue, and orange. And each pair of wires will have one solid color and one solid color with a white striping. And each of these 8 individual wires will be situated in one of the connector points within an RJ45 connection. There are 2 different ways that we can position each of our wires in an Ethernet cable, and we use a standard known as T568A and B. And if you'd like to see the individual wire pairing configurations, we have images of those in the accompanying course notes. Next, we're going to discuss a couple different ways that we can connect our computer and hardware devices to a wireless network. Our first wireless network interface is Bluetooth. Bluetooth is what we call a personal area network, or a PAN, P-A-N. This is going to be a wireless network connection that we can use over short distances. Bluetooth typically has a signal range of about 10 to 30 feet. We use Bluetooth to allow our devices to connect to wireless networks that are nearby, as well as external devices. You may have used Bluetooth in some of your common daily device usage. Bluetooth allows us to use our mobile phones as well as other devices that are Bluetooth compatible to connect with each other. Bluetooth devices go through a process called pairing. The pairing process allows 2 Bluetooth compatible devices to establish a wireless connection with each other for data transfer as well as accessing the features of the paired devices. Some commonly used devices with Bluetooth pairing are smartphones, external speakers, headsets and headphones, as well as fitness and health monitoring devices. Another wireless network connection type is NFC, Near Field Communication. NFC technology is used in our mobile devices and smartphones. It allows us to establish a wireless connection over a very close proximity. Typically, your NFC connection range will be a couple feet or maybe 1 meter. And we use NFC technology frequently for mobile payments. If you use any type of technology that involves like Apple Pay, or if you use your smartphone to conduct any type of transactions at a store, you are using NFC, Near Field Communication technology. A third type of wireless connection is RFID, Radio Frequency Identification. RFID is a technology that uses radar and radio waves to transmit data over a short distance. We use RFID frequently with our employee identification cards and ID badges. There are 2 types of RFID technology: passive and active. Passive RFID is when we will use a tag within a card or a badge, and when we approach some type of badge reader, we use it to receive a radio frequency signal that we can use to authenticate our users to access certain areas and devices. RFID is also used for tracking animals, as well as using it for part tracking when we use assembly line and industrial environments. Remember that our RJ45, which we use for wired Ethernet cabling, Bluetooth, which is a personal area network, NFC, near field communication, which we use for smartphone mobile payments, and RFID, which we use for ID card and ID badge authentication. Now, in the second half of this episode, we're going to discuss some different interfaces that are available on our computer devices. The first interface that we're going to discuss is USB, Universal Serial Bus. USB is a very popular connector standard that we use to connect our computer devices with other peripheral devices such as monitors, printers, scanners, speakers, and others. There are several different types of USB connections, and you should be familiar with each. First, we have USB Type A. This is the most commonly used USB connector. It is a rectangular shaped connection with 4 different pins. If you have worked on any laptops or desktop computers recently, all of your modern devices will have USB Type A connectors. We also have USB Type B. Type B is a square-shaped connector that we use to connect our computer devices to printers. It is also a 4-pin connector, and you will have a Type B connection on one end of the cable that you use to connect to the printer or peripheral device. And the other end of the cable typically will have a USB Type A connection that will be used to connect to the interface slot on your computer device. We also have Mini USB. This is a 5-pin connector that we use to connect to our MP3 players and digital cameras, as well as a micro USB, which is used with older photo printers and display devices. We have a newer standard within the USB grouping called USB-C. USB-C is a different type of connection because it is what we call symmetrical. That means no matter which way you insert the USB-C connection into your device, it will establish a working connection. All of the previous connector types we discussed, Type A, Type B, Micro, and Mini, will have a specific orientation or way that you have to insert into the interface slot. Besides being a symmetrical connector, USB-C is also a 24-pin connection. By having a 24-pin connection structure, it allows USB-C connections to be compatible with both analog and digital signals, as well as with mobile devices and desktop and laptop computers. Now we're going to discuss a grouping of several different interface for video and graphical displays. Our first is VGA, Video Graphics Array. VGA is a connector that we use to connect our computer devices to monitors and projectors. VGA is an analog video only connection. VGA cannot be used with any type of digital signals or audio signals. When using a VGA connection, you will also have a separate cable connection for your audio or volume output. VGA connectors are typically colored blue, and they are a 3-row, 15-pin layout. Next, we have HDMI. This stands for High Definition Multimedia Interface, HDMI. HDMI is a video cabling type that was created to replace the analog VGA standard. HDMI is a cabling type that allows us to transmit both audio and video signals in a digital format over a single cable. We use HDMI cabling frequently to connect our computer devices with monitors, digital displays, and video projectors. HDMI cables are a 19-pin connector and typically have a cable length of up to approximately 20 meters. Our next video cabling interface is DVI, Digital Visual Interface. And DVI is a grouping of several different connection interfaces that allows our computers to connect to graphical displays depending on the type of signal that we are using. We have DVI-A. The A stands for analog, and we use DVI-A whenever we are transmitting analog-only signals. We have DVI-D. The D stands for digital. This is where we can connect our computers to graphical displays when we want to transmit digital video and audio signals. We also have a DVI-I. The I stands for integrated. DVI-I is an interface standard that allows us to carry both digital and analog signals together over the same connection. We have a visual displays of all of the different DVI interfaces in the course notes, and I would encourage you to check those out to become more familiar with each of the different layouts. Next, we have Thunderbolt. Thunderbolt is a hardware interface that was created by Intel. It was created to allow us to connect different types of peripheral connections to a single computer. There are 3 different versions of Thunderbolt. Thunderbolt 1 and 2 is an interface that uses a mini DisplayPort interface. We'll discuss that here next. As well as Thunderbolt 3, which uses the USB-C connector type. Thunderbolt 1 and 2 both have a data throughput of up to 20 gigabits per second. The more recent Thunderbolt 3 allows us to increase that to a 40 gigabit per second data throughput. Thunderbolt can be used for both copper connectors as well as fiber optic connectors. Your Thunderbolt copper connectors typically have a cable range of 3 meters or about 10 feet, and your Thunderbolt fiber optic connectors have a range of approximately 60 meters or 190 to 200 feet. And lastly, we're going to discuss DisplayPort. DisplayPort is a digital display interface that was created as a standard by VESA, V-E-S-A, the Video Electronics Standard Association. It is a standard that we call royalty-free. That means it is open source and available to be used by all manufacturers. DisplayPort will connect a video source to a display monitor. We use it for both Thunderbolts 1 and 2, as well as other connectors where we want to have a digital audio, USB, or video connection. DisplayPort is compatible with HDMI, and frequently you may see some type of converter or adapter that will allow DisplayPort to connect to other types of interface connections.
That will conclude our discussion of Section 2.5, Input-Output Interfaces. In our next episode, we will move on to Section 2.6 in the objectives and discuss virtualization and cloud. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.